Right? Just let me know if you can see my screen. Functions, the differentiation of trig functions. We started this in our previous class when I had asked you to just find the derivative of the basic functions. So let's start with this one here. So the main thing for us is to remember when we differentiate d dx, when we differentiate sine x, what do we get? Anyone?
Cos x, sir.
Excellent. So basically this is why it's important that we remember these things. When we differentiate cos, what do we get?
Negative sine x, sir.
Excellent. Negative sine x. When we differentiate tan, what do we get? Yeah, so what do we get when we differentiate tan? Right? So this is an excellent point for us to study. So the derivative of tan x, I need you to work with me here, is the same as the derivative of what tan x is equal to by itself. How can we rewrite tan? Tan x is the same as what? It's a fraction of two other functions. Tan is actually the derivative of sine over cos. Does everyone agree with this? We're not differentiating yet. I'm just trying to represent tan in a different way. So tan, of course, is equal to sine over cos, right? So if we look here, the function that we have here is a quotient. Once you have a fraction, then you're dealing with a quotient. So in order to differentiate this, we need to use the quotient rule. Can anyone remember the quotient rule? If we're differentiating a quotient, we can talk about the first and second function. So this will be u and this will be v. What do we do when we're finding a quotient? Let me hear someone. What's the formula for the derivative of a quotient? What do we do with u and v?
So v multiplied by u, derivative of u, minus u multiplied with v, derivative of v, all divided by v square.
Great. So thank you very much, Dorish. So for us to remember this, right, I always like to say differentiate the force. So if I differentiate the force, it means I'm taking u prime or the derivative of u. Differentiate the force and you leave the second. Minus, so if I differentiate the first and leave the second, now I have to differentiate the second and I leave the first now. All over v squared. I have this symbol looking like an exclamation mark, right? Not v prime. Remember, it's
Right, sir.
wonderful. Cos x, right?
Yeah.
Wonderful. Now minus. So what's v prime? We're here now.
Negative sine x.
Wonderful. Negative sine x. And u, what's u?
Sine x.
Sine x. Wonderful. All over v squared, and v is cos, so it would be cos x squared, right? Good. So what's cos x times cos x? What will we get? Come on, it will be cos squared. This is how we write it, right? Cos square x. What's sine x times sine x then? Come on, talk to me. What will we get?
Sine x. Sine square x.
Wonderful. Sine square x. And will this be a positive or a negative?
Positive.
Negative.
Okay.
Positive, sir.
Yeah, so it would be a negative when we multiply, and then when we use the sign outside, then it
Yeah,
becomes
then it
positive,
becomes a
right?
positive.
Great. All over cos square x, right? Because cos square x is the same as this again. Cos x times cos x. So we'll get cos square again at the bottom. So see if you have any questions there. Tan as sine over cos. Good. So you should remember from geometry and trig that cos square x plus sine square x is equal to what? So this is one of the basic trig rules. Cos square x plus sine square x is always equal to 1. Right? So you need to remember things like these. Cos square x plus sine square x is equal to 1. So we have 1 over cos square x. Now 1 over cos x is actually 1 over cos x is actually sec x. So 1 over cos square would be sec
Square x.
square x. So that's what is the derivative of tan x. So whenever you differentiate tan, this is what you get. Sec square x, right? Is this good with everyone?